Graph a linear inequality in two variables. Linear inequalities. So a linear inequality is an inequality involving a linear function. So an example could be 3x plus 4y is greater than 12, or 5/6x minus 7 is less than or equal to y. So basically we have a linear function, but instead of an equal sign, we have an inequality symbol. When we think about graphing linear inequalities, we have a few steps we need to follow. Our first step is that we want to graph the function itself. So if our linear inequality is 2x plus 3 is greater than y, first we want to plot the function 2x plus 3 equals y. Okay, so our first step is to graph the function. Then we want to analyze what type of inequality symbol did we use. If we used a greater than or a less than symbol instead of a solid line, we want to use a dotted line. This tells us that the boundary doesn't actually satisfy that inequality. So we want to use a dotted line to represent that. If our inequality is greater than or equal to or less than or equal to, then we do want to use a solid line because that indicates that the points on that boundary line satisfy the inequality. And then our last step is to shade the side of the line that satisfies the inequality. So the way to do this, we can pick a point on either side of the line and plug it into our inequality. If it makes the inequality true, then that's the side of the line that we shade. If it doesn't make the inequality true, then we're going to shade the opposite side of the line. So let's look at a couple examples to help us understand that. So our first example, we have 6x plus 12 is greater than 3y. So remember, our first step is we want to graph our inequality. So let's go ahead. We can divide both sides by 3. I'm going to get 2x plus 4 is greater than y. I'm going to plot my y-intercept. I'm going to use my slope to plot the rest of my points. I see that this inequality has a greater than symbol. It's not a greater than or equal to symbol. So I'm going to have a dotted line instead of a solid line. And then I want to pick an ordered pair and see if it satisfies this inequality. So I'm going to choose the ordered pair 0, 0. So I'm going to plug in the ordered pair 0, 0 to this inequality and see if it makes it true. So 6 times 0 plus 12 is greater than 3 times 0. Let's see. So 6 times 0 is 0. Is 12 greater than 0? Yes, it is. So that ordered pair satisfies this inequality, which means that it's part of the solution set. So my final graph is going to look like this. Okay? All right, let's look at one more example. Here we have the inequality 1/2 x minus 5 is greater than or equal to y. So I want to go ahead and plot my points. I'm going to start with my y-intercept. I'm going to use my slope to plot the rest of my function. I see that here I have a less than or equal to symbol. So I'm going to have a solid line this time, not a dotted line. And now I want to pick an ordered pair, and I want to see if it makes that equation true. So again, I'm going to pick the ordered pair 0, 0 because it's easy to plug in. So using the point 0, 0, using the origin, I want to see if that satisfies this inequality. So let's see, 1/2 times 0 minus 5 is greater than or equal to 0. Well, 1/2 times 0 is 0. Negative 5 is less than or equal to 0. That satisfies the inequality. So 0, 0 is part of the solution set, which means I'm going to shade this side of the line. Again, if I were to have chosen that point and it didn't make the inequality true, then I would know that I needed to shade the other part of the line. So the important things to remember here, first we graph the function, then we decide if we're going to have a dotted line or a solid line for our boundary, and then we decide which side of the line we have to shade on.